Hi, thanks for watching. I found this GIF slideshow the other day and I found it quite interesting and it reminded me of something. Now, just delete the T and we've got a storm coming, and a sandstorm, and a twister, and a lightning bolt, and a lie, because that's not soil. And this is what reminded me of something. For the last couple of years now, I've intended putting a video out to explain something. And this is Angel Falls, a half-mile straight down. I'd just so much love to jump off of there. What a buzz. And this is one of the many wonders in the ocean. And this will be in the forest. And I think these geysers, you can time them, like clockwork. And that looks pretty formidable. I don't know how some people can go in that with a surfboard. Not me. Right, and here we have the auroras. And behind this curtain, you find Mount Meru. And here is proof that we don't fly through outer space at any speed. I don't know what this is supposed to be. It could be an airplane or something. And here we have, is this cloud seeding? Evaporation from the rainforest. And the sandstorm. Right, and this is a perfect example of the sun being local. Had the sun been 93 million miles away, I'm pretty sure it would light up all the water at the same time, not just the part directly below where the sun appears. And these lines here, these lights, I think they're just ships that's passing in the night. And here we have a breathing earth. Well, they're kind of right. I believe that the earth does breathe in a way, but not the way they're saying. And besides, this is more like a weather report than anything else. So, I'll show you what made me think about water. Right. So for the purpose of explanation, I'll be looking at a couple of maps. Now, this map here, you can see familiar landmasses. North and South America, Europe, Africa, Asia. And at the bottom here, we have, in place of Australia or anything, we have one landmass. And I don't know what this is, and I don't know where it is now. And also, you'll see there are 4 land masses marked at the top of this map. And we'll look at a more familiar map, the UN map. It's been adopted pretty much as a representation of the flat earth map. And I'll be using it as a model for this exercise. When I say I've been using this for a while, this here is a 1945 war map. It tells you up here, it's a global war strategy map. Right. So we'll leave the politics alone, then we'll go here. And it says, explanation of projection. This map is made on this north polar azimuthal equidistant projection. This means the world has been projected on a plane tangent to the North Pole with the parallels of latitude and concentric circles equally spaced from the pole outwards, the meridians of longitude and straight lines radiating from the pole. Every point on the map has a true direction or azimuth from the pole and also a true distance from the pole. Since it is impossible to spread the surface of a globe on a flat surface without distortion, all maps are distorted in some respect. In this map, the distortion appears in the east and west distances. This distortion increases gradually from the North Pole to the equator and then quite rapidly to the outer limits. The distortions of the Antarctic land means would be so great that they are not shown. The amount of distortion in east-west distances may be estimated from the scales panels lower. The length of the meridians is the same as it would be on a globe. Therefore, north and south distances are true. On this projection, the large in the image surrounding the North Pole are reasonably true in shape and relationship, so the map is excellent for studying the possibilities of global war strategy based on trans-Arctic air transport. So what they're saying here is the large land masses in the pole down here, okay, they just cover in snow and don't show you. Well, this is what's there, and here are highlighted 3 land masses from this map. So let's go and have a look at them. On the top right, we have got the Faroe Islands, which are down here. Right, there you go. And across here we have the Shetland Islands. And the Shetland Islands are here. Now, up in the top left, however, we have Friesland. Let me show you where Friesland is. Well, when I say it is. Right, so, there's Scotland, there's Iceland, there's Greenland, there's Nova Scotia and Canada, and here is Friesland. Well, here was Friesland, it's no longer there. How does that work then? Right, so, as I was saying, now consider all the water. I mean, we give it different names, but that's for their convenience. It's just one big puddle. So, all the water eventually ends up here. No matter where it comes from. Eventually, it'll end up in the middle. Right. And according to legend, the current is so strong going towards the centre that you'd have a hard time trying to get back out. Right, so this is the map. There's Hudson Bay, and an island in Hudson Bay. But there's this. This is cities already. This is 1560 something. Yeah. Right. Okay. Right, enough of that. When I mentioned earlier that the earth breathes, I do not mean in the conventional sense like we do. I mean it has a rhythm. And if left alone, this place has probably got better timing than a Swiss watch. In water, for example, I think there could be a finite amount of water that gets constantly recycled in its various forms. From ice melting into liquid water, with steam, humidity, evaporation, even the air we breathe. This here is Mount Roraima in Venezuela. It is approximately a mile long and a half-mile wide. Now I'm not suggesting that it's constantly surrounded by waterfalls, but when you consider it is one of many plateaus like this in this region, well, that's got to be millions of gallons of water a day. So where does it all come from? Let me speculate. Venezuela is not the only place this happens. It happens all over the earth. And I can demonstrate that. Now, I've never seen this happen on such a dramatic scale, but I have seen the process many, many times. Right, first we'll visit Venezuela. Now, unbelievably, this bit of deforestation here, you could fit England in here. That's shocking. Right, so what we're looking for. Right, well, here is the plateaus surrounded by waterfalls. And I wonder what these lines are. They don't look natural somehow. I don't know. Right, so we've got them, and let's just see what size this one here is. Well, that's small, and it's the plateau on top is 2.5 miles. Aye, almost a mile. Right, and there's more deforestation. There's more plateaus. So that's a lot of water. Whoa. That's off. Right. So we've got this as well. This is the same, this is in different levels. You can see that. How's that work then? Right, then what else we got? Aye, here. This is where Angel Falls is in here somewhere. Half mile up. So that's a whole bunch of water. Right. So I'll show you where I've seen it. Right. I see it all the time. Here. Right. So this is the start of the Highland Line. And all the hills all over Scotland, all of them are covered with small streams that start on top of the hills and create this. See, when you go hill walking, you don't need to take water. You'll always find some. And there's the same thing everywhere. These are where the water seeps out the hills and creates these gullies which go into the feeders for the lochs and rivers. And they're everywhere. Right, so what else? Right, so for here. Right. Need this Google Earth. Right, what we have. So we go down here. And this takes us in to the Nevis Range. Right. And up here, when it clears, you'll see the Nevis. This is, like, I think it's 4,000 feet. And you can see the same thing happening here. The water just seeps out the hills. And I've seen it everywhere. Right. So, it happens all over the world. The water seeps out and creates the rivers. Right, back to the map. And here we have the dead centre. This is where Mount Meru can be found. And as you can see, we've got Greenland, Canada, Alaska, Russia, Norway, Sweden, Iceland. So let's look at another map. Here's a close-up of these 4 land masses. Now, if all the water on Earth is always heading towards here, however slowly, eventually it all gets up here. Now, I found a better map. Right, so here we've got this is Scotland, this is the Orkneys and the Shetlands, the Faroe Islands Iceland, Friesland, which is no longer there, yet it had cities and obviously a population of people. And there's smaller islands. And this is Greenland. And this would be Nova Scotia, Canada, and this here is Hudson Bay, and this island is here. Right. And then they call this California, but I think it was the Spaniard that owned it at that time. And I think at that time California was an island. But the thing that struck me most about this is we've got Norway, Sweden, Finland, and you get Asia, and we have, where is it? So the only sign of Tartars or Tartaria is this. Tartar Villa in Asia. So, it wasn't a big country, it was a big house. Right, so here is the magnetic mountain, Mount Meru, and below Mount Meru is a very large version of this, and the water falls merely by its own weight, and it may even encounter shelves that are already in place to funnel it as it is sent through the rocks, and this will eventually purify it and filter it. The next thing that happens,
transportation in plants. At the end of this session, you will be able to know the function of xylem and phloem cells and explain transportation in plants. All plants need water. Plant roots absorb water and minerals from the soil. Water absorption is mainly carried out by root hairs. These narrow-walled hairs greatly increase the area over which water absorption can take place. Water and minerals enter the root by two pathways: apoplastic pathway and symplastic pathway. If water and minerals move from cell to cell through spaces between the cell walls, then it is known as apoplastic pathway. In symplastic pathway, the water and minerals move across the cytoplasm and finally reaches the xylem. Xylem vessels are long, narrow, hollow tubes containing no living material. The xylem transports water and soluble mineral nutrients from the roots to other parts of the plant. About 95% of the water absorbed is lost through the stomata present in the leaf.
This Douglas fir's thirsty roots draw nutrient-filled water toward its trunk. The tree acts like a giant water pump.
Well, thanks for watching. please comment.